So we're going to be doing problem number 2. In our problem, it says the total length of the wine well is 500 feet, and then the cable weighs like 2 pounds per feet, and then the bucket weighs 800 pounds per feet. So we have to determine how much work is needed to pull the bucket from 0 to 25 in A, and from 250 to 500 in B, and also in C from 0 to 500. So let's get to it. Okay, in part 2, what do we know? We know weight per feet of the cable is 2 pounds, weight of the bucket is 800 pounds, height of the mine well equal 500 feet. And what I want is work done to lift the bucket in 3 different situations, A, B, and C. In part 3, set up the general equation. So we're going to take the integration of the force needed to pull the bucket up. So, and A to B is our A and B is our limits, and then the dy is the change in the distance. That's how we will get the work. And then from here we break down the force into 2 times delta y plus 800. Delta y because weight of each foot of the cable is equal to 2 pounds, and the height is changing, plus 800 is the weight of the bucket, and it's not changing, it's a constant, so there's no variable. From there, we put the value of the delta y, which is 500 minus y. From there, we just solve the whole thing and get the 1800 minus 2y, and we're going to take the integration of this force, and then we'll get the work. Okay, in part 4, solve the general equation. So we're going to be solving the general equation. So we set up the general equation from part 3. So we take the integration of 1800. So since it's a constant, so we get 1800 times y, and the limit minus, we take the integration of 2y, constant times y squared by 2, and then the limits. From there we cancel out the 2, and then we get the y squared by itself.
Go.
Okay, in part 5, plug in particular information. So this is our general equation solved, and for A, our limit is going to be 0 to 250, 0 to 250. And then we're going to be applying fundamental theorem of calculus for both. So we get 1800 times 250 minus 1800 times 0 minus 250 squared minus 0 squared, and then we get 38,7500 foot-pounds. And then for B, our limit is going to be 250 to 500, 250 to 500. From there, fundamental theorem of calculus, 500 squared minus 250 squared, and then we get 262500 foot-pounds. And for C, we just add them up, and then we get the 650,000 foot-pounds.